Welcome, everyone. This is Tier 1 Interventions Podcast. I am one of your hosts, jonely Zupanzik, math specialist, and my co-host is here, co-author, partner in crime, all of those things, Cheri, an occupational therapist and neuroscience expert. We're getting ready to begin the science of math.
Hey everybody, it's Cheri here. I just wanted to give you an update on today's episode. We have recorded this at a Saturday Math, which is a free webinar that we do monthly. We follow that up with Impact Wednesday on a Wednesday night. So this past Saturday, we recorded this episode and we want to share it with you in its entirety. We're not going to break it up for you because we think it is such a powerful episode. But if you want to come on Wednesday night to hear the next segment of this, join us on Impact Wednesday at the Science of Math non-academic connections. What happens in our brain? So we're going to do a neuroscience dive into what we talked about here in the math episode at our free Saturday Math session. The link for both of them will be in the show notes, so you can sign up next month at Jonily's website on Eventbrite, or just give me an email at cheri@cheridowder.com and I will let you know how to sign up. Before we begin, please subscribe and comment on this episode. Let's tune in to Saturday Math.
Good morning, everyone, and welcome to this Saturday's webinar all about the science of math. Yes, that is what I said. Good morning. Yes, good morning to all of you. The science of math is coming, and I want to give us some details, some cautions, some warnings, and also some solutions this morning. Very excited about today's webinar. Thank you so much for being here in my part of the world, in Ohio, in the United States, snowy and cold part of the world, but it is beautiful this morning as I look out my window. And we are going to talk all about the science of math today. As the science of math begins to roll out, definitely in the state of Ohio, but also in the United States, there will be different phases of rollout. And then, of course, Canada, you'll have your own rollout. And then in other parts of the world, it's going to look a little different. And the big wave is coming for everyone, and it's going to happen in different ways. However, I want us to be informed and not misinformed. And some of you might be saying, then how do I know that your information is not the misinformation? And that is the question. Not only do you need to be asking me, but also people like me, also anyone in your school district that is narrating some of these changes that are going to come. Now, what typically happens in education is we know that a wave is coming. There's buzz about it. There might be a few professional developments about it, and then it gets stagnant, sometimes for 3, 4, 5 years. And then it comes back around. A lot of times it takes a while to get traction. Other times there are mandates that come in and things happen immediately. I think we're still walking on thin, icy water at this point, which makes me thrilled to have everybody here today, because I want today to be a foundational tool for you to use to assess against everything else that comes your way. The first question you should ask when the topic of science of math comes around, or research-based or evidence-based as far as mathematics, is, are you currently implementing in classrooms, and what results are you getting? And I think oftentimes, even when we adopt math textbooks and the speaker comes, whether it's the sales rep or the trainer, sometimes it's one and the same. It's even a question we should ask them. Who in your company is currently implementing the textbook and the ideas that you're presenting in the training, and what results are you getting? And we need to see that in real time. I think we take for face value what people are telling us and what people are saying, and then we're frustrated that we're not seeing immense scaling results in mathematics. Those are some of my cautions, and I'm going to be very direct and aggressive today. However, I want to fill your day with solutions. Again, welcome everyone. I am your host, Jonely Zupanzik, JZ in the house this snowy Saturday morning, where I am to really unveil science of math in its early stages and early form. Many times you'll hear me talk about cognitive science of learning. There are 4 components, 4 strategies, not necessarily in the education world, but in the psychological world, in the neuroscience world. There are 4 strategies of cognitive science that promote highly effective learning and retention of content. So if I'm a college student, let's say, and I have to learn information or relearn information for a midterm or a final exam, there are many strategies, but in cognitive science, I typically focus on these 4 strategies to excel learning, memory, and retention of the content. These strategies work short-term as well as long-term. I'm going to show you them on the screen, but right now I'm going to just tell them to you. So you'll just hear them right now, and I'll refer back to them during this entire session. And they are interleaving, spaced repetition, retrieval practice, and metacognitive feedback. And what I'm going to do today is I'm going to define each of those. Then I'm going to show you how they relate to teaching and learning in general. Then I will show you how they relate to teaching and learning of mathematics specifically. Then what I'm going to do is share with you some resources of the exact implementation of these strategies in mathematics classrooms. It is going to be exciting this morning, and we will interact in a moment, but right now I'm just going to seminar it. I'm just going to give you a lot of stuff, and then we'll process and interact later. So again, welcome. Welcome to all of you that know me. Welcome to all of you that don't know me. Again, my name is Jonely Zupanzik, JZ, right here, bringing to you on the front lines, science of math. And again, I will interchange science of math with cognitive science of math, with science of learning. And I'll talk about the little caveats of all of those things. But the cognitive science of math, for us here at Minds on Math, is a model that provides scalable math achievement through explicit instructional techniques. The explicit, deliberate, and intentional training is much more for the teacher and facilitator and educator, intervention specialist, rather than for the student. So there are certain explicit instructional techniques for the teacher, but then the explicit techniques and strategies for the students are different. And oftentimes during professional development trainings, we teach the explicit and direct strategies that benefit the students, which then don't allow teachers to implement in the appropriate and correct way for students to get the full advantage of the strategies. So the teaching techniques and the learning techniques are different. The action steps, the moves that we make as instructors are different than the moves that we ask students to make. And many times we don't differentiate between those two things. Just an example, you probably, since you're here on your own time, virtually, whatever part of the world you're from, whatever time of day it is, you chose to be here, you've probably been to many trainings, seminars, professional developments like this. And in those trainings, seminars, professional developments, oftentimes you get really excited. And by the end, you're like, that was really amazing. Or you might say that was really awful. But in those that you say, that was really amazing, so fantastic, I'm just going to go change my entire classroom tomorrow. You get back to your classroom and you're like, I just went through the most amazing experience, but I don't know how to do this in my classroom. And there's this disconnect between the techniques that we learn in trainings, the techniques that we teach to our students, and then the techniques that we specifically and explicitly learn as the educator on actually facilitating these transformations. And all of those have their own names and strategies. Bottom line, though, we all want the same outcomes for math. We want kids to know their facts. We want kids to be confident. We want kids to be able to work independently. We want kids to be able to just do. We want them to have the prerequisites. We want them to have number sense. No matter who I interview or survey anywhere in the world, we all want the same outcomes. But if I survey and narrow those outcomes, if I survey math teachers, instructional specialists, interventionists, if I survey the people that are currently teaching math students and helping specifically struggling students, everything boils down into the same categories. I'm going to rename these categories as we go today, but these categories are different than outcomes, so to speak, because as I survey teachers, what ends up coming out are the deficits kids have, but yet in turn, they're the outcomes that teachers wish they did have. So the three major categories of deficits and the three major outcomes that we want are computation. We want efficient, accurate computation. The other thing that comes up, most popular, no matter really what grade level, what school district, what area in the world you're in, kids need to understand, kids struggle with equations. Equations, equivalence, substitution, solving for an unknown. And the third category, nobody that I survey really has the same name for it. So what I've done is I've named this category based on all of the similarities of this category, and that's why it's a different color here. I call it shape. So for some teachers, they're like, I need my kids to understand volume, area, perimeter. I need my kids to know how to measure with a ruler. So there's lots of things like that fall into this category, but it's really all about shape and utilizing shape in mathematics and really computations with shape. Measurement is a computation. Now, these are the words that we as educators use. The words that I use, and I'm not going to give you all of the reasons I use these words today, but the words that I use are factors, meaning facts, but factors are essential. Function and fraction. So I call them the three F's: factors, function, and fraction. And all of mathematics, preschool through high school, I'd say a good 95% of our standards will fall into one of those categories: factors, fraction, and function. So at Minds on Math, we power standard, we essentialize and compartmentalize the major concepts of mathematics, and then attach the dozens of standards from every grade level to each of those categories. What that allows us to do is use the same exercises and experiences, tasks, and lessons with every grade level and every ability level of students, but we use them and facilitate them in a different way. But it all comes down to the same tasks. But I've gone off into a different path with our model. But the entire justification of our model is because kids do not remember mathematics. Some do, 10%, 20%. Some of those kids just remember, no matter how we teach, no matter what we do, no matter what we put them through. Honestly, some of the kids, they're not just remembering, they knew it before we even taught them. You have that, I'm going to be generous, I'm going to call it a 30% group of students that are going to get the math, that are going to learn the math, that are going to excel in math no matter what. So most school districts, when they're given any type of math achievement test, at least 30% of the kids are going to pass, and we cannot attribute that to what we've done. Ouch. So now we need to start looking at percentages of passing in a very different light. How do we know that we've contributed to the students that are actually gaining the achievement? So back to our frustrations as educators, why don't kids remember? It's because if I go back to the idea of cognitive science of math, the way we typically and traditionally teach mathematics is the exact opposite of the way that the brain learns. The way that textbooks are written and implemented are the exact opposite of the way the brain learns. So what do? Do we give up textbooks? No. Do we stop doing most of the things that we're doing? No, not necessarily. Because textbooks are necessary, but for a different reason. Not to implement science of math. Textbooks are necessary for a different reason, not to scale mathematics achievement. Because if we saw huge gains in mathematics achievement in certain pockets that are using the same textbooks, then we could contribute it to the textbook. But really, these scales that I'm talking about today have nothing to do with our textbook resources. They have nothing to do with our current curriculum pacing guides. Kind of a downer. At this point, you're either going to hang up and walk away and be like, then that's too overwhelming, Jay-Z. Or you're going to be like, okay, I agree with you. Let's keep going. Where's the rubber meet the road? In order to increase memory, we have to focus on teaching through the 4 strategies I've mentioned earlier. I'm going to show you those now. The 4 cognitive science strategies, and this is not me, this is not Jonely, this is not Jay-Z. I did not coin these. These are from one of my favorite resources. They're from many resources, but one of my favorite resources is the book Make It Stick, The Science of Successful Learning. Here's your authors. And the book Make It Stick is not necessarily for educators. So as a math teacher, to pick it up and be like, okay, I'm going to read this and then I'm going to go implement these things. No, it's not as streamlined as that. So what I have done, what my team has done over the years is, from the research from Make It Stick, We have then taken these strategies and implemented in different explicit, deliberate, intentional ways in math classrooms of all levels and analyzed the results. I have not coined these. These 4 strategies are from cognitive psychology: interleaving, spaced repetition, retrieval practice, and metacognitive feedback. My current work with 2 of the school districts that I'm working with right now is we are mapping their textbook resource, their curriculum resource, to these strategies within our lesson plans. And I'm going to show you a few of those examples today. But why should you listen to me? Yeah, my family would ask you the same thing. I'm going to give you a couple of examples. In thousands at this point, in the last 15 years, in thousands of middle schools, I have done a little experiment asking students to tell me the decimal equivalent for 1/8. Typically, I do this in a year 7, grade 8, right before kids go to high school. And just randomly, I'll ask 7th and 8th graders to put the decimal equivalent for this number. And this is just one class this year, but there have been literally hundreds and thousands of classes and students over the last 15 years that we've gotten the same results. And the majority of students in this specific grade 8 classroom this year gave me a decimal that had the number 8 in it. And then I had some other results. And these results are fairly typical. Now, I have also run a little action research project for the past 7 years. I began with a group of kindergartners, so 5-year-olds, about 7 years ago. And I have followed them every year. And as they move from teacher to teacher, I have coached their current teacher while we're implementing the model at their new grade level. So I will come in and actually model the model and train and coach the teacher during that school year that he or she has these students. So these current students that I've been following are in grade 7 this year, and they've been in this model since kindergarten. Now, we also have transiency. So we have kids that have moved out and moved in. We have move-ins. And so what I'm going to show you are their results from the beginning of this year at 7th grade for the decimal equivalent for 1/8. And they are this. You can notice the amount of fewer students who have an 8 in the decimal. By the way, if you don't know, the fraction 1/8 doesn't have an 8 in the decimal at all. But the significant number of students that don't give me an 8 in the decimal is really extreme from the one group to the other. And for some other information, all of these students have moved into this cohort after kindergarten at some point. 2 of them are new to our school this year. So just to put some numbers to this, and these are typical results, 26% of students in that grade 8 group give me a decimal that doesn't have an 8 in it, but 75% of the group that's been through the model gives me a decimal that doesn't have an 8 in it. Now, I don't know if that seems groundbreaking to you, but it is to me, just with that one example. And if we look at other results, we have seen cohorts of kids go from 27% passing the year-end assessment to 60% passing in less than a year and 92% showing growth. We also had a really cool group of students last year. Typically and historically in grade 4 at the end of year, EOY, end of year, end of course math exam that the state provides, typically fourth graders in that district and surrounding districts, there are usually 50 to 65% of those students that pass. After 2 years of partially implementing this model, funny story. So I've been working with these teachers, the fourth grade teachers, for 2 years at this school district. And in the middle of last year, there's 2 fourth grade teachers, they both said to me, jonely, like, we're really trying, but we're not even doing half of what you've taught us. And boom, last year, 84% of the entire fourth grade level. So this is the entire fourth grade. So they have about 130 students at that grade level. 84% of those students passed that end of course math exam. And we just continuously show results after results. It is very powerful. And I share it not to be like, so you guys are probably like, just show us your strategies, jonely. You all that are here today, you didn't come to be convinced. You're here because like you want to know what to do. But because we're recording this and because I want the science of math intro session to be all wrapped in one bundle, it's important that we have some validity behind us. And it's important that you all hear that. There's more where that came from. But again, I don't want to bore you. I want to get to what do we do? But it's important that when someone is bringing in training, professional development, a new initiative to your district, based on what I've said today, are how you should formulate questions to ask about the validity of the strategies that they're bringing in. We at this point need to question everything. So let me back up for just a minute. So this is Saturday Math. We do a once a month Saturday session. It's completely free. You register on Eventbrite. Here you are today. You found us. We typically focus on improving number sense. That's our go-to on Saturday Maths. Improving number sense is the number one thing that we need to do to swim in this science of math area and improve memory and achievement. So we're still on that topic. But for the rest of this year, each month that we do Saturday Math from here until June, not only are we going to be focusing on improving number sense, each Saturday I'm going to share with you a different strategy, a different example, a different implementation, facilitation technique that you can go back and use right away in your classroom. And you can use that strategy or technique for 10 minutes one day and see really impactful results. It's not anything that takes a lot of time. As a matter of fact, I don't want it to take a lot of time. Spaced practice from cognitive science says, or spaced repetition, I interchange that. Spaced repetition means that we need repetition over time, but in very small chunks with space in between. What that means is if I give you a strategy today and you're like, okay, I'm taking that strategy to the limit. The way that you implement it is next Tuesday, you do 10 minutes of it and that's it. Then a week later, you do another 10 minutes. And then 2 weeks later, you do 20 minutes of it. That is spaced repetition. That is spaced practice. And what that also involves is that first strategy called interleaving. Interleaving is just out of context learning. So if you're in college and you're studying for midterms, in the Make It Stick book, in other research articles and journals, it is said, if you have 4 midterms, don't study for one midterm at a time. Study for 30 minutes, one content, 30 minutes, a second content, 30 minutes, a third content, 30 minutes, a fourth content, and then repeat that cycle. That is interleaving and spaced practice, because interleaving is out of context. It's switch tasking your brain, which is necessary for the muscle to strengthen and remember more. Think about math textbooks for a moment, y'all. I'm sorry to be the bearer of bad news today. You think of chapter 1, all similar concept. Chapter 2, all similar. What happens is we're doing the exact opposite of interleaving and space practice. Do you burn your textbooks in a bonfire next weekend? No. Especially if they're digital, that would be, it's a new concept. What we at Minds on Math do with schools and teachers and districts is we open up the table of contents of the textbook and we pull nuggets from each unit and chapter that become our, here's a new word, stimulus. This is a Minds on Math word. A stimulus is a trigger that's going to stimulate mathematical thinking, reasoning, and sense making. But we pull these right from our textbook. Now, I have some that I've generated that are really good stimulus that are transferable from one grade level to a next and They come from textbooks. They come from released test questions. They come from the ACT. There are some at Minds on Math that are our go-tos, a couple dozen of them. But you can also randomly pull from your textbook. What we do is we help teachers and school districts look at your textbook and implement it in a different way that involves interleaving and space practice. That's some of our structure. Just as I'm glancing at the content or at the comments as well, it's interesting you ask this question because one of the schools that I work with is we have gotten these results in schools from urban, rural, large schools, medium schools, small schools, private schools, Catholic schools, you name it. We have the entire sampling. And the one school district that I work with right now, I work in one of their schools that is a 7-8 building, grade 7, grade 8. The entire building is 7th and 8th graders. However, there's about 600, 700 kids in the school. The majority of these students have either learning needs, brain disconnects, special abilities. So they're being served with IEPs. And a number of these students are ELLs or SELs or students as a second language. Many of the students in this particular school have come in not speaking any English. And so we also, alongside our regular classroom teachers and intervention specialists, we train, and there's other models, the SIOP model, there are other trainings and other models that when you bring the science of math pieces into it, it just enhances the other really good models we're using for those kids that have English language disconnects and barriers. So great question. Great question. Keep those questions coming in the comments. I may not answer them right away, but I'll keep glancing over. And then I'll also ask us to have some dialogue together today as well. So as we are thinking about everything that I've said in this session so far, where is your brain right now? So let me ask it a different way. What are your current thoughts? And I invite you, you don't need to turn your video on. You don't need to engage. You do not need to interact. But I do invite you to put anything that's swimming in your brain right now in the comments, or right now, just unmute and give me your wise words.
I am liking your construct of the interleaving and the space repetition because all the kids that I do work with are kids with diagnosed learning difficulties. And the thing that I find the hardest with the math concepts is they can't switch from one thing to the other. If you're giving them something to do, it has to all be the same thing because their mind can't go back and forth between two different things. So to me, to be able to teach in that way where you're not keeping them on the same track over and over again makes sense, I think, to
Good
make
point.
those connections work in the brain.
Absolutely. Good point. And really, if you think about end of year exams, final exams, midterm exams, state assessments, problem number one has nothing to do with problem number two. So, what we're asking kids to do on an assessment does not match our day to day instruction. And it actually doesn't match our day to day lives. I have to switch. We as human beings have to switch tasks all day long from being the driver of a car. And okay, so right now, my role as a human is to drive on the road to get myself to work. Then I have to switch my brain from my road rage traffic incident. And then I have to start working. But then I get a text from my kid's school. Then I have to jump back into work. But then I get a call from my boss about another meeting. We are setting kids up for failure by not using this model.
I wanted to pop on just a second and
Oh, yes, Sarah, good. Yes.
yeah, I just wanted to first validate what Kelly said, because that is pretty big for you to recognize that it's hard for your students to go from one thing to another. And I feel like it's unnatural for you to then think about what Jonely's saying and be like, oh, I should try to switch back and forth more. Because what I tend to hear from teachers who say the same thing that you did is that then I have to keep them in the same, we have to just do this, and I need to lay it all out for them because they aren't able to do this or that or switch focus, whatever the case may be. And we keep doing the same thing, but we're also getting the same results, which then I also hear in our multi-grade level meetings, what you said earlier, Jonely, that students aren't remembering from one unit to another or one grade level to another. And they're like, I know you've seen this before. I know we did this before. And why are we having such a hard time remembering it? And I just appreciate the conversation about like how the brain learns what we know now and how do we keep pushing forward to kind of change things so that we get the results that we really want to see.
Well said. Said. Other thoughts?
Habits. Habits drive our day, 90% of it. Our brain wants to do automatic activities. It doesn't want to think.
Amen.
So we tend to do what is automatic, what those pathways are that we've developed that are currently working like in this circular loop. And if we try to take that loop and put a little fringe in it, our brains go, wait a minute, confusion. And so we're looking at it from this. So looking at it from that perspective, where anytime you put a little blip in the brain, it's going, no, I want safety.
I'm going to be real for just a minute. From what I hear, I'm in dozens and dozens of schools every year, sometimes every month. I get around. When I first started teaching in 1999, I'm a secondary math teacher by trade. I was not going to be a teacher. I actually have a math degree. I have a Bachelor of Science in Pure Mathematics. Knowing that, you can really understand my disconnect when I started teaching eighth graders mathematics with a Bachelor of Science in Mathematics. Who knows more than me? And I would teach my kids brilliant lessons and they would not get it. Talk about a personal struggle. And to have that background, that really set me off on a journey of, I have a degree in mathematics and I don't know any mathematics. Now, I say a lot of that to just give you a little more background. But if I go back to Teresa's question in the comments, what holds districts back from applying these techniques? When I'm in dozens of schools, because I had my own classroom, I was in one school district for 15 years. And then I went on this journey, which I had to branch away from that district because sample size. I've got to go out and try these things with lots of other places. So I've done that for the past at least 12, 13, 14 years to see if it happens everywhere. And what I hear from teachers is, but we have to use our textbook. We have to use it page by page. But then I talk to their administrator and their principal will say, that is not what I told them. They need to use it as so everybody's blaming each other because of what Cheri said. Nobody wants to change their habits. So because they're resisting so much, it's very difficult to say as a human being, I know I need to do this change. It makes complete sense. And this is all rationally, subconsciously. I know I need to make this change. I know it makes sense. I don't know how to do it. I don't even know where to start. It's overwhelming. And then what comes out of their mouth is, yep, my principal says, no, I have to do it. I have to go page by page. There's a lot of disconnect in communication. Now, the other answer to your question, Teresa, which is why I'm pretty aggressive today, and I want all of you to hear me today and stay connected. As the science of math emerges, whether it's in a year or in 5 years or 15 years or 30 years, at some point, this recording will be public. This recording is what we need to point the fingers to. Not because I'm all that. I am, and a bag of chips. No. Y'all, I'm a lot. I'm a lot. Stop it, Jay-Z. Anywho, not because I'm all that, but because we need to begin questioning everything. Because another answer to your question, Teresa, is what dictates what happens in schools? Oh, I'm really going to get blasted here. Is driven by government and money. I have no affiliation with the government, and I have no affiliation with big money business and kickbacks from any textbook company or anything. I have no connection at all. My company is Minds on Math. We are a service provider that consults and coaches to support school districts with the materials that they have, with the mandates that are in place. We're not asking you to break the rules. We're just saying you can implement the rules differently. So what we do at Minds on Math is we support school districts with their current model, their current resources, their current mandates. We ask a lot of questions to say, okay, is this one really true? And then we start to rethink how we deliver what's being told that we have to do. Thoughts, comments, questions? Go ahead and unmute if you have any.
I think there's also a fear that teachers have that, especially if you're mathy, whether you're mathy or not, if you're mathy, we learned this way, we were able to do it this way. And so we think that's the way. Math teachers, more than any other specialty in education, tend to teach as we were taught. So it's hard to break away. It's hard to have to sell it to your administrator. It's hard to have to sell it to parents. And we don't want them to come at us and say, why are they learning 3 different ways to subtract? I learned one and I got by just fine. So why are they wasting time? So it's this fear that we have that if we break away from the mold, even though we know in our hearts and in our heads that it's probably the best thing to do, because again, definition of insanity, doing the same thing over and over and getting and expecting different results, it just doesn't happen. So we need to break away, but it's fearful. It's very scary.
Fear. Amen.
It's interesting you say that, Kathy, because I literally had this huge, long discussion last year with my principal, particularly about a particular student. She's like, why are you teaching them 5 different ways to do division? And I'm like, because that's what the requirement is. And that's what they're going to look at on the testing. When they see testing, they're going to get hit with it 5 different ways. And every kid doesn't learn it the same way. And there is more than one way to do math. And they should be exposed to all of them and then pick what works for them. And she goes, I think one way is just perfectly fine. And I'm like, I think that too, but I don't know. I don't know what y'all think about that, but I think they do need to be exposed to all the different ways so that if they can figure out what works for their brain.
And Kelly, your next follow-up question for that person is, how does that relate to how the brain learns information? It all has to come back to the science of learning. Right now, in a few of our states, we're having this really large battle and controversy with science of reading. And I get it. And I'm not a literacy person. I'm not going to get into it. I'm not dying on that hill. I don't really care, honestly. But as I sit back and watch from an outsider, and I watch the debates, like Kelly, you're talking about these 2 different opinions, 2 different views, it's still not grounded in cognitive science, the science of reading. I think we need to really question. You all should question me. You don't take what I'm saying today at face value. Please don't. Please don't. You all should question me. You should question anyone that comes and says, how does that relate to how the brain learns? That's the bottom line. That's the bottom line. Now, okay, we can swim in this for a while, but I had started something a while ago. I am so nonlinear. Look, if any of you have ADHD students, or you've met an ADHD student, or you are ADHD, okay? When you talked about that before, about the kids sticking with one thing, blah, blah, blah. Who thrives the most on interleaving and spaced repetition are ADHD kids. They don't want to stick with one thing. When school before has ousted our ADHD kids because we're trying to get that square peg in a round hole, we're trying to change the kid to focus better. When in all reality, ADHD humans have the best focus. Actually, they're hyper-focused, but they're hyper-focused in switch tasking, which is the way the world works. So we should actually cater our instruction and our environments in our classrooms to the ADHD brain and train others how to be able to do this. We're doing the opposite. We're trying to conform everyone else to the non-ADHD brain, when really what we should be doing is embracing the ADHD brain. I was a very type A, linear, structured girl. I followed the rules. I did what I was told. Give me one example, I'll do the rest. I went into teaching. I had my day. I had my structure. I taught my kids in that way. Then I realized I was teaching them nothing. It wasn't working. Always thought I was going to be a girl mom, going to dance competitions, having my cheerleader follow in my steps. Then I had 2 boys. Boys are not typically type A. Yeah. So this mama was like, everything I do in my life works against everything I do in my life. So I am no longer, actually, I am so far type A now that I need to reel it in. I need to reel it in because it's like you can't walk through my dining room right now. You've seen like those episodes of Hoarders. Anyway, that's besides the point. Let me back up for a minute, because my point is I can't teach now in a linear way. It's just not in my nature anymore. When I said to you, what I'm bringing to you today, each Saturday from now until June, I'm going to be bringing you snippets of the same stuff. But I want to unveil for you now this year's June event. If you guys have been around for a while, if you're new, then this is new for you anyway. But if you guys have been around for a while, you know that every year annually we do a June event. And before COVID, all of them were in person, and it was a room, tons of people, all math educators, administrators, just the whole thing. It was a whole big one-day party of mathematics with lots of learning and lots of networking and lots of collaborating. And since COVID, our June events have always been virtual. They're still great, not the same flair. Our June event this year, my friends, is back to in person. So get your plane tickets. Get them right now. All right. What I'm going to be doing on Saturday Maths for free from now until June is little samples of the cognitive science of math. The June event is going to be a full day. Bring your team. Okay. We're going to be in Granville, Ohio. That's close to Newark, Ohio, very close to Central Ohio in the States. So you're going to want to travel for this. We're going to have a full day on this topic. You will walk away with all of the materials, the audios, the resources, the worksheets, the lessons, the slides, everything you need to support your implementation of the cognitive science of math. Now, at the bottom of the flyer, it says in-person Granville, Ohio. We have not finished our contract with the location, so it's not in writing, but it's 98%. We literally have to tie up the loose ends. It's a whole thing. But the event will be held at the Cherry Valley Lodge. And I'm not sure if their address is Granville or Newark. It doesn't matter. They're right beside each other. But the Cherry Valley Lodge in Licking County, Ohio. It is a hotel and event center. Oftentimes they'll have weddings there. They have a beautiful courtyard. They've got a pool. They have two beautiful living room areas in the lobby, fireplaces. Not that in June we're going to be sitting around the fire drinking hot cocoa, but it's an amazing event center. And we have as big of a ballroom as we need to have based on our registrations. And it's a full day on everything I'm teaching you now. We are not going to go back to what I did this morning. We are not going to go back to all of the convincing and the why and the data and all of that. Anyone who registers will get this recording that we will say, you need to preview this before you come so that you have all of this information. So we don't have to repeat it on that day. We want to jump right into the structure of the solution. We don't want to massage the problem all day on this day. So I put this flyer in the chat, download it, print it out, make copies, email it to people, share it. You can actually scan this QR code right now if you want to register right now and jump into it. But now, even my certified coaches here, we've got Amy Garrison, give us a wave. Krista Ewing, give us a wave. We've got Teresa, give us a wave. Cheri, we've already heard from Cheri. Cheri, give us a wave. Even our certified coaches have not heard this yet. This is the unveiling for everybody. This is this year's June event. We're super excited about this annual event. What's not on this flyer, which is also coming, is that evening for a small extra fee, we are going to have another micro event dinner for alumni. So anybody that comes to the June event has also an option to purchase the 2.5-hour dinner training for alumni of Minds on Math from the 15 years that we've been in existence. We've reached out and surfaced old school districts and teachers that we've worked with, and we're going to continue to do that up from now until June. But we're going to have an alumni dinner training, which is separate from the day training. So you can either attend both, or you can attend one or the other. And during that alumni training, we're going to talk about really the evolution of mathematics teaching and learning and where we are now and the best next steps. So we're going to really streamline the whole path of where we've been, where we are, and where we're going. And then just have an opportunity to maybe meet people that you've been in trainings with and it's been years. And so it's just going to be a nice dinner party, networking, collaborating event, and it'll be that same evening at the same location. So I'm very excited today to unveil that, and I am just thrilled to bring that to all of you today. Let's see, I'm going to catch up on the chat here. Interleaving, da 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 da.
While you're doing that, I just want to say anybody in Eastern Pennsylvania, Sarah, I know Teresa's not technically there, but you have to come through Pennsylvania. We can all carpool together.
There you go. Look at that. Through this model that includes interleaving and space practice, yes, it doesn't matter if kids are absent. I could have kids missing 40 days a year, and they're going to get exactly what they need. As a matter of fact, when I partner with classrooms, because I'm in classrooms every day, every week, when I partner with classrooms and it's my classroom, like I'm not the teacher of record, but the teacher has agreed to partner and collaborate with me. And then I am infused in that classroom all year on certain days at certain times or certain parts of the year. I am never in the same classroom more than 2 days a week for 30 minutes each day. So the way that I plan a year of math now for any grade level and any classroom, I plan it so that you can teach all of your standards in 2 days a week in 30 minutes each of those days for mastery. And the results that we get come from that model. Because a lot of times, if I'm with a teacher 1 day a week, I'm with certain teachers 1 day a week, every Wednesday at the same time. I teach that teacher's class every single Wednesday at the same time. Depending on the comfort level of the teacher, he or she either tries to replicate what I do the other days, or just says, look, I love the 1 day focus on this, but just for my sanity, jonily, I've just got to do my other 4 days the way that I do math, which may not be the model. As a coach, I've got to give that teacher the flexibility and autonomy that they're comfortable with. I chameleon coach, meaning I change my color, I change my outcome, I change my goal, depending on the teacher that I'm working with. Because the last thing we already have a teacher shortage. The last thing I want is to overwhelm a teacher and have them drive their car off a cliff. Come on. We've got to customize this for each teacher. We've got to differentiate the level of implementation for each teacher. And as a service provider and instructional coach, that's what I do when I go into schools. And I customize the model that matches the teacher's comfort level and personality, because everybody is different. And it's not fair to dictate that everybody does the exact same thing.
I have a question.
Yes, question.
In your model where you're doing all the standards in 2 days, 30 minutes, whatever.
Yep.
How does that work for the kids in the classroom who are on different levels?
Beautiful. All right, here we go, Kelly. Are you ready, Kelly? Are you ready to rock and roll?
I am ready.
Kelly, I love you. All right, so here is, in the last 30 minutes, here are the goods. Okay, here are the goods. Okay. Oh my gosh, there's so many answers to your question. Okay. We have the entire model mapped out. We have everything. We have the whole course. We have everything that you can follow scripted. I am not giving you everything today. I'm going to give you one example. What I'm also going to give you today is you can actually purchase a bundle for $40 today Don't do it now because I haven't even told you what's in it. Don't just blindly do this. You can purchase a bundle today for $40 that shows you the exact first 5 days of implementation. Not only is it the first 5 days, let me show you what you're going to get. You're going to get a link to this Google Drive, because what we actually have at one level is called the 15-day formula. So we actually venture to say in 15 days, and they don't have to be consecutive days, in 15 days you can do this. So we have a 15-day formula. Then we have the 15-day formula cycles. We create then a 60-day formula. And then we have what your question is, Kelly, that is like, how do you make this all fit in your whole year? Okay, but that's too much to answer today. What I'm going to share with you today is day one. I'm going to share with you what one day looks like. And I'm going to share that right now for free, but if you want to purchase the bundle, you can click on that link, pay the $40. It's not an automatic download. You'll get it within 24 hours, but you'll get this Google link that has audio lessons of me, yours truly, teaching day one in a 2nd, 3rd, and 7th grade classroom. Now, there are more audios than this, but these are the ones that I literally just did last week because I always like to stay fresh, relevant, and current. Now, if you are a 6th grade teacher and you're like, oh, I'm out, there's nothing for me. No, you don't understand. It's the same task. It's the same task. If you're a 6th grade teacher, listen to all 3. If you're a high school teacher, listen to all 3, okay? You're also going to get day 2 in the 3rd and the 7th grade classroom. And also, I'm going to add this in, I didn't, but you're also going to get day 3 for the 7th grade classroom. You're also going to get some additional audio lessons that are from other days that are just really good models of this. You'll get 3 or 4 of those audio lessons. You're going to get 4th grade, 5th grade, and high school there since you don't have those here. What you're also going to get are the slide decks that I'm going to show you right now that I'm going to teach on. So this that I'm showing you right now that you'll get in that bundle is the first 5 days of what we call the 15-day formula. And if I want all standards to happen all at once, interleaving, space practice, everything that I've mentioned, the other thing that I didn't mention is we have to boil math. I did mention at the beginning, we have to boil math down into the essentials. Do you remember my 3 F's? Love me some F words. Factors, function, fraction. So what we've done is we've analyzed all the math standards preschool through high school, and we've said these ones are essential. We've also done surveys with teachers. You don't care about all that boring stuff. But I need you to trust me that what is selected here is the most essential, most important, that leverages all other content. So on day 1, here's what I did on day 1. And this is in January. So on day 1, I showed this to my 2nd graders, 3rd graders, 7th graders. Now, let me give you some context. The 2nd and 3rd graders I've been working with since the beginning of the year. One of those classes I've been working with for a couple years now. The 7th graders I just met 4 days ago. This is a brand new group in a brand new school that I just started this model randomly on Wednesday. So my 2nd graders had never seen this symbol. And the 7th graders, I didn't know if they would have ever seen this symbol or not. Now, the square root symbol doesn't really explicitly state in the standards until grade 8. First of all, that's our biggest problem with deficits in mathematics about the standards, but don't let me get on that soapbox right now. So don't dismiss this. If you have a group of kids in 4th grade and you're like, okay, I need a different stimulus because I can't show them that. Yeah, no, you have to trust the system. Trust the system. You show this randomly out of context. That is part of interleaving. And you propose to them to tell you about what they see. So what I did in the 2nd grade, 3rd grade, 7th grade, and you'll hear this on the audios. If you purchase the bundle, you'll get the audios and you'll hear me do this. And you'll hear me do it different ways with different grade levels. That's why you need to listen to all of them. And I'll say to them, tell me about this. Tell me about now. The kids that I've been working with, you're going to hear 3rd graders and they're going to be like, that's square root. And you're going to be like, how the flip do they know that? And what is she doing to possess these kids? My 3rd graders they're a group that I've worked with for 2 years now. So they're very comfortable with square root. Okay. Now, my 2nd graders, they were like freaked. Okay. You'll hear in the 2nd grade audios how I handle that and then what I relate it to. My 2nd graders have done a problem this year called the pizza problem. A pizza company makes square pizzas. Let's make squares. I give them blocks, they make squares, they draw squares on paper. What math questions can we create? What numbers make squares? If you purchase the bundle, you must listen to the 2nd grade class and us talking about square roots, because they are relating this to pizza problem and they're talking about pizza problem and numbers make squares. And a couple of the 2nd graders on audio, as we were just exploring and playing and having conversation, a couple of the 2nd graders said, I think all of the even numbers that she said, I think that all numbers that are even make squares. She created a conjecture. So we took her statement. We've got her statement. We did not prove or disprove it. I just brought it to the class and said, hey guys, we have this statement. We don't know if it's true. In math, I like to play a game called Always, Sometimes, Never. This could always be true. It could never be true. It could sometimes be true. But Allie says that all even numbers can make squares. And then we didn't really explore it. It was about the end of class, but I want you to listen to that in that 2nd grade audio. Because my 2nd graders had an advantage. They had never seen this symbol or anything, but they have had experience with the pizza problem, just making squares. So if you decide, you know what, before I do day 1, I want my kids to play with the square pizza problem and make squares, you could do that. Then when we say, okay, tell me about this thing, I will then explicitly and directly say to them, this symbol is called a square root symbol. You don't need to remember that. You don't need to remember it at all. But what it means is there's this check mark and then this line here that is a side length of a square. Okay, friends? We want to check the side length of a square, and that's how I talk through this symbol. We want to check the side length of this square. Because if this is the side length of a square, and I make a square, if I make a square, and I can actually draw a square over top of this, what this symbol tells me is that my square pizza has 50 pieces inside. Now, kids, let's make that square pizza, because the square root says, what is the side length of a square pizza with 50 pieces of pizza? So then I give them grid paper, I give them blocks, I give them exactly 50 blocks. And the goal is to make a square. My kindergartners can do this. My high schoolers can do this. It is appropriate and necessary for everyone.
Jonely, I put the link to the Pizza Problem ebook in the chat.
Fantastic. Hey, we're just upselling you everything today.
What is the Pizza Problem ebook? It has the first 7 interactions of the pizza problem that you can do with kids.
I know you all are like, oh my gosh, I could go next week and totally just, if you told me what to do every single day, I would just do it. And that's not the best first step. Okay. Ease into this bad boy. We do have the program. Now, Cheri could put Cheri, put the link in the chat. I'm going to tell you guys to ignore it, but put the link in the chat for tier 1 interventions, because we do have the entire course. The tasks that we use boil down to our dirty dozen. There are 12 tasks. If everyone preschool through high school uses these same 12 tasks, that's it. There's 12 of them. You can teach all of your standards and more, and be able to teach all of your content in 60 days or less each school year. So this works very nicely if you have a textbook resource that you guarantee your principal told you you have to teach every page of. Okay? You can still do that and this. So Cheri, if you put in, the pizza problem ebook, that's another little upsell there. Now we do have the entire course. It's a year-long process. When you purchase this course, you get once a month live training. Next Saturday is actually our first of this 12-month process. If your school district has money and you can go back this week and be like, I want the entire course, the Mastery Math Method entire course, tier 1 interventions, is, I can't remember how much, it's like $1,400 and some dollars. But what that will get you is, we actually launch our new cohort group next Saturday. We do a once a month, 2.5 hour live session. If you can't go, everything's recorded. It's uploaded into that module. You get all of the previous modules. So you get all of the recordings, you get the entire course, plus for 12 months and an entire year, you get a live training with Cheri and I as well. Cheri's by trade occupational therapist, neuroscience expert. So when Cheri and I collided, I as the math expert, education expert, Cheri as the occupational therapist, neuroscience, brain-based expert, medical expert. Cheri worked with stroke victims. So she worked in adult therapy early in her career, and then school-based therapy, occupational therapy, the second half of her career. And when our worlds collided, my model for mathematics exploded, because now it was directed to cognitive science before, but now it's grounded in neuroscience. So Cheri and I partner on a lot of this, and Cheri and I partner on the tier 1 interventions, the Mastery Math. So if your school district has an extra $1,400 to drop, you can start with us next Saturday. It's a 12-month membership. If you've got 5 or more people, email me. We'll get you a discount on it. If you want to bring 5 or more people, we'll get you a discount on that.
But jonily, just
go
so
ahead.
just so everybody's aware, I put 2 links in the chat underneath the pizza problem ebook. The reason for that is the course is, you'll get lifetime access to it. So as long as we have this platform up and moving, you will have access to it. The coaching is a separate fee. Just logistically in the system, we had to break it down and make it a separate fee. You will see 2 prices there. If you want the conversations with jonily and I, that one time a month that jonily just talked about, you need to get the coaching part as well as the courses themselves. It was a technical thing to create the bundle. The question, if you look at the courses, if you just go on to all the courses for disability labs and you see all the dark parts to it, all the dark things with the squares on it, there's a question there. How does automaticity and pattern recognition support, answered by the locker problem? I didn't say it exactly correctly, but so we've gone through and we've analyzed each one of those tasks that jonily talks about, and we've aligned them with what it means neurologically and how that particular problem fits the math standards. Jonily has taken a lot of time to identify which math standards are, from K through 12th grade, go with every single one of those problems. The reason I talk about the locker problem is because my personal opinion is it helps OTs understand the math situations much better than starting out with the pizza problem. For you as math teachers, you need to start at the pizza problem and work your way out. So I talk about the locker problem a lot more because I'm talking to OTs.
Michelle, I love your comment in here. My favorite quote from Science of Reading. You guys, beneficial for all, essential for some. We've not ever done that in mathematics. We've tried and we've made some transition and we've made some gains. But if we want significant scale, this is the way to do it. So let me go back to sharing my screen. I'm going to share with you a little more than this because I ended up skipping this with all 3 of the levels. This is in day 1, but I skipped it because I do a lot of responsive teaching. And day 1, after the square root problem, I decided it was better to go to a quick dot because the square root was a little intense, especially for my new group of 7th graders. And I didn't want to freak them out. I wanted to get them back to a little bit of a comfort level and an access point. So what happened was I said, I'm going to show you a quick dot. A quick dot is I show you quickly for a few seconds, take it away. I show them this quick dot for about 4 seconds. I take it away. How many dots? Kids love quick dots. Love, love. Then we analyze how were the dots arranged? How did you see them? Tell me about this. And then if that quick dot was stage 3 of a pattern, tell me about the pattern. What you're going to hear on the audio recordings that I do this Purple X is you're going to hear all of these math standards come out. We're going to start to talk about linear, nonlinear function. We're going to start to talk about chunks versus overlaps versus dots, how the stage number relates. We're going to talk about how to figure out how many chunks or dots in the 100th stage. And then what you're also going to hear, and then I skipped around, so you'll have this information in your slide deck, but I skipped around, and what I did was responsively, I went to penny jar, which is similar to a quick dot, but penny jar is a little easier to see the pattern for kids. So we made a lot of connections there. You'll see that I skipped around a little bit in my days, but then when I went back on day 2, boom, we got right back into the slide deck. Now, let me show you what I did on day 2. Okay. If you are not implementing division in the way that I'm about to tell you, you are missing out on a deep opportunity. Here we go. You ready for this teaching? You ready, Kelly?
That's okay. Jonely, just before you go on, when you're talking about division,
Yeah.
I put in the link to Tier 1 Interventions podcast episode that went out this week on division. So it's also in the chat.
Cheri! Oh my gosh.
Awesome, because I'm getting ready to do division with my kids next week.
See, this is why I need Cheri. I am a highly functional adult. Don't get me wrong. I make a lot of stuff happen. Better than most people. But I do not attend to detail whatsoever. Cheri, you are so brilliant because yes, Cheri, how could I forget? On the 7th, the podcast dropped. Watch it on YouTube and subscribe, guys. But I totally forgot that on the 7th, what I'm about to tell you right now is an entire podcast for free. Watch it on YouTube and subscribe. Actually, click that link, that YouTube link, copy that link, send it to 20 people this weekend. Tell them to watch and listen to this podcast on YouTube and subscribe. Come on, do it. We'll pay you. No, I'm just kidding. We won't pay you. Okay. Oh, I forgot to tell you. If you really do want to jump into the entire Tier 1 Interventions course next Saturday and drop that boatload of money and you even want to bring your team and get a discount, and we can work with you this week to get it all situated. And I know POs, purchase orders and everything take time. So if you get approval, but you don't have your purchase order yet, you can come in and start to join, because we know that process takes time. We'll work with you on it. But if you sign up for the $1,400 12-month bundle, we'll give you your registration for the June event for free. $450 registration to the June event that I put the flyer. We'll just add that in included. Registration for the June event, absolutely free if you purchase the today's tier 1 intervention bundle. All right, what's happening here? I'm teaching you. I get caught up. Okay. The pure essence of division is skip counting. Division is skip counting. This division symbol says I'm going to skip count. I'm going to divide up my counts into equal parts. I'm going to skip count by the second number, 0.5. I'm going to skip count by 0.5 to land on 8.5. 0.5, 1, 1.5, 2, 2.5. Okay, so I'm skip counting by 50 cents. I'm skip counting by 1/2, however, whatever. How many of those skip counts does it take to land on 8.5? This works with every division problem, with every type of number. Now, Kelly and Kathy, I'm going to go back to what you had mentioned earlier about having kids exposed to lots of different strategies. I agree with that, but there's a more powerful level. The more powerful level is a transitional level, meaning there are certain strategies for operations that transfer easier into different number systems. For example, with division, there's lots of different ways to do division. There's the way that you make division fraction, or the way that you do groups of, or number in each group, or all of those strategies are important. But the transferable way has the most impact. There's always one strategy that transfers for all kids, and they're always triggered by that one strategy in a good way. And that is the bottom line. Division is skip counting. Now, how they skip count can be differentiated, but the bottom line is division is skip. You start with this number and you skip count to this number. If I have 6 divided by 1/2, I skip count by halves to land on 6. Now, if I have 231 divided by 7, I'll put that in the chat, 231 divided by 7, same thing. You skip count by 7s to land on 231. And what some of you are going to say is, yeah, that's not efficient. My goal is not efficiency. My goal right now is for kids to just understand, oh crap, that's a lot of skip counts. That's all I want them to care about. I don't even care that they know exactly how many, because then what I'm going to do is I'm going to say, okay, then how can we efficiently skip count? Gosh, with 7, if I could get to 70, I could skip count by 70s. Oh gosh, that gets me to 210. Then I have 21 left over, which happens to be a multiple of 7. I'm not facilitating this very well at all. But the bottom line is, every time we see division, it's a skip counting to land on a number. And that needs to be universal as we're teaching as the transferable strategy. Same goes with subtraction. I won't get into subtraction. That podcast will come out next week. Now, the reason I say that is my third graders, if you listen to the third grade audio, day 2, if you purchase the bundle for $40 and you listen to the third grade audio, what we were doing at the third grade level on day 2 was we were creating a square because we went back to square pizza, and we were creating a square that's a 50 by 50, and we were trying to figure out how many pieces of pizza were in that. And so they know also that multiplication is rectangle. They know when they look at the square pizza 50 by 50, they know they're doing the multiplication problem 50 times 50. They know they're finding the area of that square. Now, third graders, we only focus on single digit multiplication. My third graders, they don't know double digit multiplication, but they can access it because they know multiplication is rectangle. When I said to my kids, okay, with 50 times 50, what's my skip counting number? My skip counting number is 50. And then I said, how many times? And they're like, oh, 50. And my one little guy, oh my gosh, the cutest little chunkiest fellow ever said, yeah, I'm not doing that. I think you'll hear him on the audio saying that. What I love about what he said was, and I had him say it to the whole class, I said, I love that you said that, Dylan, because here's why. Because you have the concept that skip counting by 50 times is not worth your time right now. That is a mathematical understanding that you can't teach, and you can facilitate it. You can ground kids in experiences where they're going to refuse to do it because they know it's too many skip counts. Then the point becomes, but we still have to figure out how many pieces of pizza. So how can we do it more efficiently than skip counting by 50 times? And then we don't have to answer that question, but I just want kids to know that there is a more efficient way to do it. We're just not going to do it today. But then I have kids like skip counting by 50 because they want to know. There's no harm in that. What's the harm in kids skip counting by 50 if they want to? That gives you a little glimpse of part of one of the models. And if you get the bundle, you'll get the audio recordings for the first 2 days. I need to add in day 3 for 7th grade because it was actually really good. I want you guys to have it. And then you'll get day 4 and 5 also. You won't get the audios for those, but you'll get the slide decks for day 4 and 5 so that you can see the other tasks and stimulus. But if we go back to where we started today, the science of math is coming. It's going to be presented to you by either someone that has no idea about being in a classroom with children, or it's going to come to you from somebody that has no idea the science behind how the brain learns. And this is going to be uncomfortable because those people might be from a big company or corporation that's going to try to convince you because they're good. They've been trained in sales and not neuroscience. Don't let them fool you. Or the government is going to make expectations about the science of math. And obviously, we can't change that. I used to think my purpose here is to change the system. Yeah, that's never going to happen. I gave up on that years ago. My purpose here is to take whatever mandates come to us and manipulate the implementation so that we're still covering the mandate, but we're doing it grounded in the science of learning model that I've talked about today. It's coming. How are we going to react to it? I do have a few minutes to stay on today. I am going to formally close us out for those of you that need to leave. So don't feel bad about jumping off. The training is done. Thank you for coming. Look for in about a week for the registration for next month, February, Saturday Math on Eventbrite. Follow Minds on Math on Eventbrite. Don't forget to save all of these links here in the comments because you can save the chat right now, or you can copy and paste all of those links in the comments to a Word document or a Google document. Have all of the links, even if you don't click to purchase. I want you to have all of them because these are special links for today's session. And although they will continue to work over the next 2 months, they won't be necessarily re-advertised, and especially at the same price. So even if you don't purchase anything today, if you have the link at the price today and you've saved that and you have it in a file and you can click on it, you can always purchase at today's price today, or like in the coming months. So save the chat or copy and paste all of those links that Cheri and I put in from today. Go back and spread the word. Start listening to the Tier 1 Interventions podcast on YouTube and subscribe. And subscribe is what is most important for us right now on YouTube. So,
And comments.
And this is just selfishly. This has nothing to do with your growth and your professional learning. Selfishly for Cheri and I, so that we can become the go-to experts, if you want us to become the go-to experts. Selfishly for Cheri and I, you must go to YouTube, Tier 1 Interventions Podcast. At YouTube, search Tier 1 Interventions Podcast, like and subscribe and comment. And if you can do that and get 20 others to do that, I'm totally lying right now. Thanks all for coming. If you got to jump, I'm going to pause for a moment and then I've got about another 10 minutes. I can hang on for questions and comments. But this was Saturday Math, brought to you by Minds on Math and focused on the science of math. And we hope to see you in February. Bye, everybody.
Somebody's asking how to save the chat. If you go up to the three dots up next to January 2025, click on that. It'll open a thing that says save chat. Hopefully that if you're not on your phone, it makes it much easier.
If you can't save the chat and you're having trouble, email me and just say, hey, can you send me the chat? And I'll send you the PDF of it.
I put just a summary of what's happening in the next week, of how to see us live, free event on January 15th, paid event on January 18th. There's the link for Tier 1 Interventions podcast. Thank you, Alexa. Thank you, Paula.
Hey, you're welcome. You're welcome. Lots of thank yous in the chat. You're welcome, everybody.